Hey everyone, welcome to the April 2021 Gio Community Call. Today our agenda is a short update from Elias about the compute backend, followed by a dive into a 4K demo tool whose name I'm not sure how to pronounce. Want to help me out there?
It's pronounced sointu.
Sointu. All right.
And what does the name mean?
It means it's Finnish and it means a chord, and it's a reference to the polyphonic capabilities of the synthesizer that we developed.
Awesome. All right. Well, I'm gonna hand things off to Elias to get started.
Yeah. So my update will be very short because I wouldn't say knee deep, but I'm still working on the bugs and performance issues of the new renderer. I think it was Chris that raised both of the current GPU hang issues of the renderer on the issue list. One of them is on the Intel graphics card, and another one is on NVIDIA graphics cards, both on Linux. And I have seen some, not exactly GPU hangs, but I've seen some problems on my Android device where if you switch away from the app and switch back to a GU app, then there will be a one frame of corrupted rendering. So that's the bug sides. The other side of it is that the new renderer is faster than the old one on newer graphics cards or more capable graphics cards, which means that it's faster on newer phones, newer Android devices, and it's also faster than the old one on desktop GPUs. But there's still I still have some issues getting it up to the same raw speed as the old renderer on older phones, such as my own Pixel 1 device. Fortunately, I'm going to switch away from the performance work a little bit because I really need to wrap this project up and push it towards being the default one, fixing the rest of the bugs and so on. So what I'm going to do is I also have a fallback renderer as I spoke about. I think that it was the last or the previous call, a fallback renderer if your GPU does not support the new renderer, in that the CPU will do most of the work, which is then uploaded to the graphics card and then displayed. And for that to be performant at all, I need to have the sections of your UI that do not change, have that cached on the graphics card, and then reuse it from frame to frame if it hasn't changed. So kind of a graphical hash from rendering operations to the resulting images on the graphics card. So that work will most definitely speed up the CPU fallback. I hope enough of a speed up that it can be used without too much pain on slower devices, slower Android phones, and so on. But also, more importantly, that feature will also be active if you're using a TPU for the compute renderer, in which case the rendering performance should be much faster than the old one, or at least at the very least of comparable speed, even on older phones such as my own Pixel 1. So that's my current focus right now. I hope to have, I'm not sure I'm going to make it in this month, but it really is my sort of my milestone / goal that I'd like to be to fix the hang bugs and the performance issue on older phones in this month. And so perhaps late this month or the beginning of May, I can switch over to making it the default renderer, so we can shake out all the rest of the issues. So that's about it for me. Oh, I have the Plato app feature. People would like me to are interested in doing games and on the desktop and using GPU for the UI for those games. And in that sense, they'd like to improve the interaction, the features of integrating GPU on top of something else, which could be a game or something that you have customly rendered, which is not rendered through GPU, have that ability enhanced so that you don't need a different window platform API to do that. And the example of that in the GPU examples repository is the DLFW example, where we use GLFW for the window and input, and this use GU for the to render just a button, but it could be any kind of UI. And what Plato wants to do is to have the GU window support custom rendering, and of course to have GU user interface rendered on top of that. So I'm going to work on that quite soon. So if you have a project that also needs that, then you may want to follow that work as well, as soon as I get started on that. So that's about it for my status update.
All right. Well, I think we can go look at sointu.
Cool. Hello, everyone. So my name is Veikko Sariola. I'm doing this project purely for hobby. Let me see if I can share my slides. Second. Now the challenge here, if I'm going to do live demos, can I actually share audio too? So do you hear my computer?
I don't think that we've tested that before. So
Let's see. Okay, so can you see my screen now?
Yes.
Fantastic. Okay, so I'm working on this project called Sointu. It's a synth tracker for 4K intros. Now, there's already could be a few words that are not so familiar to all of you. What is a synth tracker and what are 4K intros? I'll get to that. First of all, this was not a project originally that started by me, but this is a fork of an older project called For Clang. And what this is essentially an app for making music. And what it includes actually that after you've made your song with this app, it includes a tool that you can use to compile a song into assembly code. And this includes x86 or the 64-bit variant of it, or WebAssembly. And what you get actually after compiling the song is simply a single function that you call, and it outputs the song rendered as a waveform that you can then very easily play using any kind of you can just send it to audio output. So I said 4K intros. 4K intros means that file size, the total files of these programs that this is intended to be used for is 4 kilobytes, like 4096 bytes. And of that, you can't expect to use all of it for audio. So the audio typically has something like 1.6 to 1.3 to 1.6 kilobytes reserved for the audio side of things. So after compiling song to song, you can typically expect something like 2.5-minute song take approximately 600 bytes, or that would be only the song data. But if you include also all the synthesizer code, then the total code will be something like around 1.3 to 1.6 kilobytes after being compressed. Now, as you might already guess, the user interface to this program is completely written using Gio. And so, no, not that one. So, what is a tracker? It's mainly, there are many different software to make music, but not all of them are called trackers. And tracker is mainly about how the user interface is organized in the software. So in a tracker, you organize the song in what's called tracks that are represent different sounds being played simultaneously. And what is characteristic of these trackers is that the time flows from the top to the bottom. You have rows on which each row you can trigger a new note, and typically one beat is something like 4 rows, but this could vary with one song. And you have patterns, which are phrases of notes, typically 16 to 64 rows long, and then you have an order list in which order this pattern appear in songs. And there's a long history of trackers. They actually started probably first ones. Well, the first really popular ones were on Amiga back in the early 90s. Then there was popular trackers on MS-DOS, and now Sointu is following the idea of these tradition of these old trackers. That here you can see the user interface of Sointu, and one track is basically one set of sounds being triggered in parallel, and then a pattern is like a short phrase within this track, and these patterns can be repeated, and the order list here tells the order that the patterns appear in this song. So it's a little bit difficult to explain like that. So let's just jump to the software. Can you see the, I hope you can see the Sointu now here.
We can.
And so let's grab actually a new song. And now the challenging question, do you hear sound if I play that one? Did you hear any sound?
Not
I did not.
currently. No.
Yeah. Okay. So I don't think that this is. But anyway, this is how you would input the notes to it. So you could do and maybe some note off commands, and then you could scroll up, hit play, and then different notes are getting played. Now, what is characteristic of these trackers is that they're heavily keyboard driven. Probably the early computers that used that these trackers were developed on didn't even have a mouse. So one of the things that I am really trying to do here is to make the whole UI also to be usable solely on a keyboard. And that's actually one of the, like, trackers really look like a, you know, it's about as sexy user interface as a spreadsheet, but there is some power user mentality to it, because modern music software generally tend to be organized around two metaphors, like the metaphor of sheet music that you write, like from the left to right, you draw these notes with your mouse, or it could be like more like a sampler, so you are manipulating these kind of waveforms from left to right. So I don't think that there's like a pre-computer metaphor for a tracker interface, but it's once you start to learn to use it, is rather powerful. Okay, so let's go back. Right, so here. Okay, so what is a 4K intro? It's a form of recreational coding. It's an executable program with a maximum file size of 4096 bytes that produces visual effects and sound. The typical running time of these programs is something like 1 minute to 5 minutes. And it's what's called a demo scene activity. So the programs are typically submitted to a competition where people get to vote for what they think was the best entry. If you are interested to see actually these 4K intros in action, you can find them from this website, Poet. Over here, there's lots of 4K intros released by different people. Few examples of the kind of visuals you can see there. Few examples you can see there. And actually, the 4K intro down here called Adam was the first one that I did with by using Sointu. Okay, so I said something about modular synthesizers. Well, of course, in the early analog days, modular synthesizers, this is how they look like. So you manipulate audio signals by really literally by plugging these kind of cables and running them signals from one unit to another, and this is what's called a patch. And of course, modern modular synthesizers typically ain't analog, but they're software. But you still maintain the same kind of mentality that you draw these kind of boxes that could be oscillators, they could be filters, they could be envelopes, and then you connect these boxes, the signals in these boxes in various ways. So you manipulate essentially this kind of a node graph. So so how does this node graph then get actually converted into something that can actually be executed on a some kind of a machine that does the audio synthesis. Well, this kind of simple node graph, for example, where you have where you have an oscillator and noise coming together, and they add it together, multiply by envelope, and then run through a filter and then send to output. This, what you could do is that you convert it into a kind of a stack machine. So actually in a stack machine, you are running a program where you first run an oscillator that pushes one signal on the stack. It's an oscillator signal. Then you run the command noise that pushes the noise signal on the stack. Then you execute operator plus, and you add up the noise at the oscillator. Then you push envelope on the stack, multiply this envelope with the sum of the noise and the oscillator, you filter it, and then you send it to the output. So this is essentially what the original Forklang project does. So instead of inputting the program in the form of a node graph to have a graphical user interface, Forklang really gave you like a pretty low-level programming language of sorts that you could write to be executed on this kind of a virtual machine, and stack-based virtual machine. And this is a screen capture from the user interface of the original Forklang, and you can here see quite clearly, if you zoom in a bit, you can see that there is an envelope oscillator, there's some arithmetic, there's some delays, panning, aka effects, and then you send it to output. Forklang was a project written in C++ and assembly, and it worked. It's mostly Windows only, because it was like a VST instrument, an audio plugin that you were supposed to use inside a digital audio workstation. And after you've compiled, written your patch in Forklang and composed your song in a digital audio workstation, then you could click here, export in the program, to export it into assembly code. Now, when the COVID-19 lockdown started, I thought, okay, I'm going to need a project here because I'm going to be bored if I don't have one. And I noticed that Forklang wasn't too actively developed. And I looked at, okay, this is starting to show its age, and the last commit was from 2019, and I think even those commits were kind of like the main development had already like taken place much earlier, and those was just some minor updates there. So let's fork Forklang. So Sointu is now a fork of Forklang, and the project goals were simple. So clean it up and test the assembly code. So there was no regression test or anything, and I was worried that if I started to do too much to the program, I'll break everything. So I wrote simple test cases using ctest. Now, another goal of the fork was that let's make it cross-platform. Let's get rid of the audio plugin stuff, the VST stuff, and let's get rid of Visual Studio and Windows stuff, and let's use CMake for the builds, and let's write all tooling using Go. And then because now we don't have the VST tool anymore to compose songs, then let's make a tracker-style GUI with a keyboard-friendly UI that should be responsive and fast. And of course, let's add more features, stuff that was missing from original Forklang. So what Sointu can do, and this is our new feature since Forklang fork, we now made it to target all three major platforms: Windows, Mac, and Linux, and probably a lot of other related platforms, anything that supports System V ABI. And second, one quite interesting thing is that we rewrote the whole audio core also to support WebAssembly. So it can compile the songs also into WebAssembly codes. We added support for 32 and 64-bit builds. Forklang was just 32-bit builds. We made the tracker using Gio. We added new audio effects, beat crushers, compressions, BPM modulations, new capabilities like sample-based oscillators, unison oscillators, polyphonic instruments. And one interesting thing to you guys is that there is now a pure Go implementation also of the virtual machine. So none of this, if you don't compile it into some generate the code for these platforms, you can also run all of this in pure Go. And so maybe it's a little bit unfortunate that you can't hear the sound. Can I make a, let's see, let me quickly see, is there any way to make a sound sharing on?
Yeah, so I did a quick search and I found some indication that, and it looks like you're in Chrome, like Chromium-based browsers, supposedly there is a checkbox somewhere in the screen sharing flow where you can share system audio, but
Hey, I found it. Sorry, I was just being stupid. Can you now?
Yeah.
Hey, fantastic. Okay, so this is a one simple pattern here. So let's do something. Let's okay. So now I have like pattern 0 repeated like 2 times, so immediately it appeared over here, and then I have like a second pattern, something else here. A simple song here. Okay, so that's note of commands to those nodes. Okay. And okay, so a word of warning: you might have loud noises. So so apologies in advance if I because you never know what happens when you're doing your modular synthesis stuff. So that's how we put some notes in, and we can hit space and we get them played. We adjust the BPM over there. Here's where you see the it's a kind of small probably there, but here's where you see the stack-based virtual machine, and the number here shows how many signals you got in the stack. Okay, so we envelope, we put one signal on the stack, we have an oscillator on stack, we do mulp, which is a multiply of these signals, so it's envelope times oscillator, and we add a bit of a delay effect there, and we pan the signal and we send it to the output. So for example, I can do change the signal. Okay, so that would be not even very modular, because now we're just adjusting some parameters in the sound. But we could do, let's add a filter to this thing. So something like and let's add a little bit more unison to the. So let's make the whole thing stereo, so you have a little bit more interesting sounds. Just quickly, let's make some kind of a. So that's basically how you make sounds. I have made a little bit more interesting sounds as an examples. So let's grab that instrument. Oh, whoop. So, and let's add a few tracks there. Let's grab a bass, and we need obviously a kick. So, just a second, let me. Yeah, that's okay. Yeah, okay. We can do. Yeah. And okay, so let's stop here before I ruin your ears. You get the idea, so you can quite quickly repeat using the idea of tracker where you manipulate patterns and then you repeat the same pattern over and over again. You can quite quickly compose songs, especially where you can the repetitive sections get repeated with the patterns. And the modular synthesis here it gets kind of complicated over time, but you just add different units or filters or things after each other. And it's usually sometimes you have a very good idea that you're gonna do, so that you are trying to, for example, replicate the way that some well-known synthesizer works, or then you can just explore and add more effects, filter stuff after each other until you find something interesting. So let's get back to what I think. Let's get back to the presentation. So, okay, 4K intros. What's the point of making just these small programs, these audiovisual presentations? Well, is there any real-world use case for this? Do you still see my camera, by the way? Maybe not. So.
Don't see your camera anymore.
Yeah, okay, that's fine. So some of the ideas for the future features that I think that we might go where the directions that this Sointu project might go is that you might use this one to embed sound effects in Go executables. So maybe you want all your notifications, beeps, and ringtones in less than 4 kilobytes of data, and you could have them embedded in your Go program through Go generate. So, and this could use the Go only written virtual machine. So this would be a highly portable way of to wherever you can run Go, then you can run this. Maybe you could use this to put music in QR codes, because the sound data for a typical song is less than 600 bytes compressed. So that easily fits a QR code. You can put something like 1 kilobyte of data easily in QR code, even with an error correction. You could use Sointu as a dynamic sound engine. So instead of rendering the sounds as samples and then playing back samples, maybe you are running Sointu all the time, and then you're generating dynamic sound effect for games by synthesizing them real time using the Sointu core. Now, my experience with Gio, what I think is great about it is that most of the screen in this program is updated very often. So the tracks, the volume meter, scopes, and all that. Scopes are not implemented yet, but they are redrawn almost all the time, and that makes it a great target for EM GUIs So that's why I think that I went with Gio in the first place. The second thing was the very little garbage aspect, because an audio program is a little bit like a real-time bound. So we should be able to. I mean, a big garbage collection event could cause audio stutters. So we want to avoid as much as possible garbage. I think IMGO is in general, and of course Gio also, is great fit for manipulating lots of tabular data, because imagine having to creating a widget for every cell in that tracker. Now as we are zooming in and zooming out, the number of cells always changes. But with IMGO, none of this is a problem. We just draw what fits on the screen, and that's it. Now, something I find a little bit like annoying, and this is more maybe a fault of the Go, but lots of my code ends up looking like this. So it's a function of GTX, a giant cascade of functions. Maybe it's just the way I write it, but I find it that lots of time I end up doing this with Gio. And then just one thing, which is that the lack of widgets, or at least some way to find them. So maybe I should just show quickly some of the widgets I had to do. So you see the scroll bars. I ended up implementing myself. Probably would not implement them anymore, because I heard that there's now scroll bars somewhere to be found, but I didn't find them, so I wrote them myself. I had some cross-platform that claimed to be a cross-platform file dialog library, but that didn't work that well on all, like on Mac, for example, when my friend tested it on Mac. So I ended up doing my own file dialogs. So this is, and of course, this being an IMGO, you can see that it's pretty responsive. So as soon as you type something there, you get always the directory listing. So that's very nice. I actually like this file dialog more than the Windows default ones, but still, it was a bit of a work that was besides the point, in the sense that I was more interested in writing audio software and not writing file dialogs. Yeah, something like menus and pop-ups I had to write. But I guess that you guys probably have done all of this. I just couldn't find them when I searched for it, and that could be one thing to improve, that people find these widgets from somewhere.
Can I ask?
Yeah, you can. That's actually at the end of my presentation. So you're now free to ask anything.
Can I ask, where do you look when you're looking for, widgets for Gio? Like, where do we need to put them to make them discoverable?
I think that I basically the two things I looked mainly was the Gio org, and then the Go docs. That's basically mostly where I look for stuff. Or I don't know. I mean, I'm really new to Go, actually, in to start with. So this is the first time I'm writing Go code. So
wow.
so I have no idea of where to actually even people typically put their projects on with Go. So but I would assume I would think that linking to cool places on Gio or cool widgets there would be very helpful to get started and avoid re-implementing stuff, avoid overlapping work.
Okay. Yeah. So, did you ever come across the repository called Gio X?
Oh, I did when it was pointed to me that this is where to look for the event spy, and that's when I first found this project. Maybe I wasn't paying too much attention. Maybe it's mentioned somewhere, but no, I didn't pick it up.
Okay. A number of we haven't got every single thing that you've mentioned that you had to write for yourself, but we have some of them. in there. That's where scroll bar is. That's where our drop-down menu kind of implementation is, and a few other things. But I mean, that discoverability problem is real and it's important. So I wonder where to link that from.
Are there Geo examples that include all the widgets from Geo Extras?
There are, but and maybe this was a mistake. They're currently kind of under the directory. So if you go to the Geo examples directory, there's a folder called X, and inside of that is all of them. But I wonder if that actually makes them hard to find, because that is a very small nondescript name. So like, how many people actually explore that folder?
Yeah, I think that the that was maybe just something for you to consider, that you would
absolutely
make it a little bit easier. And I think that for example, maybe I've done something. I mean, okay, first of all, I just learned how to use the key focus. I mean, I didn't even understand all the concepts of Geo very thoroughly, and I had implemented something like a key focus, complete my own key focus, until I really understood how it was supposed to be done. So I am in the process. So that is all to say, my code is at the moment a bit of a mess, but I would be happy at some point to contribute back and put some of these stuff. I actually think the project is currently under MIT. Is that an issue for the licensing?
So all of Gio's core and examples and the kind of extensions to Gio core are dual licensed under the MIT and the unlicensed.
Right.
And we can't accept contributions into those repos that can't match that.
Yeah, but I guess I can still contribute the widgets just by licensing them as a on the dual license.
Yeah.
So if there's something, if you know something that you would need, and I think that definitely at least the scroll bar should be part of the main repository. I think
I agree.
That was I think that was
the scroll bar should be part of the list widget.
Yeah,
and I think I wrote it to you as well. I don't think anyone has just come around to doing that yet.
Well, so I get stuck mentally when I think about integrating a scroll bar, because scroll bars have varying styles. If you want to match the platform style, especially. So, and the layout package where list lives is kind of theme agnostic. Nothing in there actually presents content. It only structures content. But a scroll bar is very much a presentation element. And so I have not yet come up with a way to structure
You can have the list export queries for where the scroll bar is, the size of it, and so on. And then you can have a material package list actually rendering the list with scroll bars on, for example.
Yeah.
Because I think the hardest part, maybe not the hardest part, but at least a non-trivial part, is figuring out where to position it, how large is it, and so on. And that has to, I can't see how that is not somehow integrated with the list, because it needs to know how many elements there are, what are the sizes of them, and a heuristic for determining, to guess what the entire list is, what the complete and total list size is, and making and sizing the scroll bar accordingly.
Well, let me tell you, if you're not inside the list, it is non-trivial to figure all that out.
Exactly. So I think the list should, at the very least, export whatever is necessary to just draw it, and then we could, I suppose, we could have a material list that displays a materials scroll bar.
Okay. Yeah, that makes sense.
I think that would be because I would expect any native list element to have the scroll bars included, and that's probably what you experienced when writing your program that you added a list and the scroll bar was not there, then it must not have been implemented. That would have been my guess as well, at least.
Okay. That file dialog is interesting. I know Pierre, I believe, has also been working on a file dialog. I don't know how that's coming, but he is here, so maybe he can.
I presented one a couple of months ago.
Yeah.
It's probably a bit too complex for standard usage. It was more an exploration tool for many different, things like sliders and specific type of lists, etc. I do have a much simpler one though. Using standard Geo library, no fancy stuff, which I might put somewhere and share with the community, and then at least get some. Move the ball forward in terms of what do we want or what do we need and where.
Okay. Yeah.
Regarding this, yeah, go on.
It just seems like that is a thing that a lot of people are needing. So trying to build a community implementation of that, I think, is really high value.
I was using, I think it was some Squeak Dialogs or something like that. I don't remember what was the name of the library. Something I also found from the internet, but really it didn't work on Mac. So my friend tried to use the tracker and got stuck because the dialogues just didn't open up, and somehow it was related to something that he was not running some Cocoa stuff, and then the dialogue were not spawning at all, and this was not even the dialogues were not designed to be used without making a window first. So the problem with that one, that finally I had to dump that whole thing because the dialogues were also crashing on some Linux that tried, and I only have Windows. There's nothing I can do about it. And then I said, look, the only thing I can do now is to write my own file dialogues, because it doesn't really, otherwise it's never going to work in a very reliable way on all platforms.
What were you saying, Elias?
Oh, I just wanted to mention that other than moving the X examples out in the main directory, we could also somewhat, let's say, let people explore the examples easier by running them on the TOUI website. So on the front page, there's just a kitchen demo, but we could, and there's the architecture document with all the small examples, but we could have, let's say, just say full screen links to full screen pages that runs each example, at least the ones that are relevant and can run on the web.
Yeah, that would be, I think, very helpful.
And the website code is actually more or less prepared for this, because at least the kitchen example is generated just as Go builds for WebAssembly, and it uses the actual kitchen example module and package path, and then it generates the WebAssembly version of that, puts it in somewhere that is linkable. So when you export the website to the when you upload it, the kitchen example is actually the kitchen example of the version you have in go.march. So it shouldn't be too hard to have the other examples work like that as well.
May I ask a question?
Yes, absolutely.
It's Christophe here. Are you using a high resolution screen?
Yes, I am.
Yes, but it's for the application that we just saw. Excuse me, Elias.
Mm-hmm.
Okay. Not necessarily that has a high resolution. I think it's it's 1920 by 1200. Is that I don't think that's.
No, it's not the number of pixels. It's the pixel size in DPI.
No.
It's a standard LCD with
standard
72.
LCD. Yeah. Yeah, I think I might have some code that doesn't scale properly for high resolution displays. I realized that I should do the more of the unit DP. I mean, the oldest part of the program probably doesn't do the properly, so it doesn't convert from using the unit DP conversions. But there's some pixel values, maybe hard coded still there.
Okay, I asked that because I found your text very crisp, so it's nice. Thank you.
Interesting. I've done nothing. That's all thanks to Gio. If there's any crisp text, I didn't do anything to make the text crisp.
I wonder if it's better looking in terms of crispness because it's light text on a dark background, and I don't know what that does in terms of the gamma correction, but now I would be very interested to actually see your 4K demo that you built using this, if you want to show that off.
Sure, if you want.
Me
It's
too.
going to take 2.5 minutes. So what I'm going to do is I'm going to play it on YouTube for the funny reason that my computer is not powerful enough to watch my own 4K intro. The trick here is, see, you plan it to be shown at the competition where you are participating, but they always have a monster GPU on their computers. So what you do is that if you hit something like 2 FPS with your old laptop, you can sort of expect it to play nice and smooth on the in the competition, and I did exactly that, and that's a bit of a sad that you can't watch your own intro. But so let me show you. So let me share my screen. Share my. Wait just a second. Let's share that one. I hope you're seeing that one.
I see a black rectangle.
Yeah, share your screen. I forgot to click that share audio. And then let's go to YouTube.
Is anyone seeing YouTube?
Yep, just a second. Here we go.
I see. Okay.
Oops. and just to prove
Wow.
that.
Did he drop off?
I think maybe we had a misclick on the stop sharing button or something. That it boggles my mind how that can be 4 kilobytes.
I wonder, I'm going to ask him as well, but I wonder how he synchronizes the music with the graphical, or rather how he does the graphical composition, how he develops the visual side of the demo. So any other questions while we wait for the demo coder to return? So Chris, you actually tried to implement a scroll bar for list ones, it seems.
It's in
No, in the core. Or did you just
I
research
spent a
that?
little bit of time investigating how to do it, but as you know, List is a complex creature, and I ran up against, I wasn't certain how I wanted to handle that separation of the presentation layer, so I didn't go much further.
Okay.
So I never had a proof of concept for that, but it wouldn't be too hard. Well, I say that. We have a working scroll bar implementation, perhaps not as nice as some. I haven't actually looked at Loki's scroll bar, but if it is actually aware of the true dimensions of the underlying surface, then it's going to be a lot better at the expense of computing the dimensions.
But I don't think you want that in general, right?
No, you probably don't.
At least the whole point of when I wrote list is to avoid determining the dimensions of, and you pretty much have to do that in an immediate mode GUI, because you can't just ask for its dimensions or, hey widget, would you like to give me a cheaply calculated dimensions or estimate of it? You can only draw everything and then throw it away and have the dimensions from that.
Well, I've wondered about having like a, I don't know what to call this type exactly, expensive list that incrementally determines the dimensions of the underlying off-screen widgets. Every frame it speculates further out from the current visible elements and just renders one thing that's not on screen to get its size information. So after a few frames, it has like a decent understanding of at least the local region of the list's average size per widget. That would be more expensive.
That in list as well. It's no problem to just draw a few more elements to each side, even though you're not going to draw them you're not going to render them anyway, just for its dimensions. I don't think that's awful. The awful thing would be to estimate every item in the list, especially if the list is procedurally generated. So welcome back to you, Veikko.
Yeah, I think I accidentally closed you at the same time as I closed tried to close the YouTube. I don't know which part you missed, or did you see the 4K intro still playing?
We did see the video.
Yeah, good. So anyway, that was the important thing. I think I didn't realize that I closed the call. I was just wondering. Anyway, so that's stupid me.
Can I ask you how you do the rest of the production of the demos? The visual side?
That's all. Well, okay. So there is a tiny executable that basically does nothing else than it's a simple C main function that basically starts up OpenGL and loads the shader, and then calls sointu to render the song. And so by this time, sointu is compiled to like first to assembly, and then using assembler to a object file. And at this point, basically, we link that one to this main file. I mean, with the main function, and and the magic there is by this time also the shader has been it's a string, but it's actually minified, so it's a very compact shader. There's a shader minifier tool to make this pretty short. And what happens next is the real magic which revolutionized 4K intro development was a tool called Crinkler. It's a linker. So people take this hobby pretty seriously. They write their own linkers just for this purpose, okay? And what's the reason to write their own linkers for this hobby is that the linker actually doesn't just emit the code, but it emits actually a small decompressor stub. It's like a self-decompressing executable, and it emits this kind of small decompressor stub, which is pretty crazy because in something like less than 250 bytes, they managed to beat the decompression algorithms of the standard deflate and all that. I mean, slightly worse than pack compression algorithm, but given that it's only like some 250 bytes or something like this, the algorithm itself, maybe it's something like that. It's pretty insane achievement. So that Crinkler tool is also a linker, not only a compression algorithm, because what it actually does is it juggles around the sections of the code and the data to find a perfect ordering for the data and the code so that it compresses as well as possible. Mm-hmm. So that enables pretty crazy amount of compression into this 4 kilobytes, and since that you can basically, it could be as much as 12 kilobytes uncompressed, depending on how much you have repetitive data in your program. And in my case, for example, you notice something funny about my song, that it has, maybe you didn't notice it, but there was something funny about my song. All the notes were E3, E from the octave of 3. So most of the notes were around there. The reason I did that one is that I actually did that. If I have a bass, which would be like 2 octaves down, I actually repitched the oscillators so that all of the data is E3, which is actually hexadecimal 64 in the notes in the data. So most of my data is either zeros, that nothing is there, or just hexadecimals of 64s. And the reason to do this is that you try to make the data as low entropy as possible to have it compress as well as possible in the end. Yeah.
But how do you actually produce it, develop the demo? This is the compression part and the linking part, which is
right.
Kind of
right. So
product.
That's the end product. So you have, it's a gigantic shader. It's just one shader. The whole thing is just written a shader. Basically and if you know, there's tool called Shader Toy online that you can try your pixel shaders inside your browser. So I'm very newbie in that field. So there are people who do this only shaders. They don't write the code or the audio, but they just make shaders, and they make beautiful, crazy shaders in this website. For example, Shader Toy, where you can find a lot of these. And that's where I did a lot of the prototyping for the shader. That if you are wondering how to do that 3D stuff in a 2D pixel shader, well, the magic is in you write a kind of like a ray marching algorithm that finds you define your geometry as a combination of different primitives, and you find the how when your ray hits each of these primitives using the technique called ray marching. And so that's where you get the shader. And actually, I didn't mention that, but I actually had a simple version that plays the song using sointu. So I played the song using sointu, but then I send the synchronization data, the different signals from the audio to the using RPC to another Go program. And my other Go program did what it did only. It loaded the shader from the hard disk and then showed on screen. And now I had actually all these flashing lights that I did was actually some audio signals driving the lights in the screen. So what I actually did is that I was able to do same thing I do with the audio that I can just try different parameters and move these sliders around. But I was actually sending that not as an audio signal, but as kind of like abusing the tracker and the user interface I already had for making the sound for making all the visuals to synchronize to the sound. So, but in the end, it was, I would say, still last few days, I was just hitting F5 and watching the 2.5 minutes over and over again and seeing like, okay, there's a bad thing in the last few seconds that I want to change. And then I had to watch the whole thing all over again. So I've seen this pretty many times by now.
I imagine.
So yeah, but this was my first 4K intro. So I'm really also like just getting started with this stuff. So this was the first 4K intro I make for Windows or for PC platforms, and but it's a great hobby. I mean, you learn so much with it. I mean, it's a very educative to learn all this because you are looking at the assembly code generated by these. You look at the assembly code of what is generated by compilers, and you finally understand what a C++ compiler does. I mean, it has been always a mystery to me because it's so hard language. But now I finally start to understand what happens under the hood.
That's certainly impressive. I really like the idea of implementing, using the Go virtual machine to embed sound effects. Like I could see using that for cross-platform notification sounds and other things from Go applications.
Yeah, that's at the moment it's not really easy to do. I mean, nothing. It's really this is work in progress. But I was thinking of making really that okay, maybe you have some kind of a static data, maybe some little bit like Icon VG is, that you would have this kind of static few hundred bytes of data, and each of them would be actually a sound that you can just ask for sointu, and then you get basically a waveform, for example, 16-bit PCM that you can just dump to Auto or something like some other library to a soundboard, and voila, you have some different kinds of beeps, ringtones, stuff like that in your Go program. So maybe some merit to it. I mean, you could imagine that there's, of course, nowadays people are watching cat videos from the YouTube and then spending like gigabytes of data. So I think that, people worrying about sending a few kilobytes over the internet is a little bit, time from the past. But still, maybe also instead of transferring the whole package of sound, you could send just this 10 kilobytes, and that would be already 1 hour of music or something like that. It could save bandwidth if you are in that kind of a business where this is important. But certainly certainly Sointu isn't ready for Google, so it'll take some time before cleaning up things and testing everything and doing everything like really properly. I mean, it's barely working. In the tradition of demo scene tradition, things are barely working. But the first 4K intro I did it was just to demonstrate that okay, you can do finally something with it.
Egan, what did you mean by your question of scrolling the demo?
Oh, I just meant that rather than rewatching the whole video all the time, you could seek to the place you want to rewatch.
Okay,
yeah, right.
I think that the question was a question of state. So the question of like if you watch it the second time because of things are not implemented in a beautiful way, the state might change and it might not look exactly the same on the second time you watch the whole thing. So I kind of did that because when I scroll around now in Sointu and when I have run the small Go program, it actually shows the time kind of properly. But I ran into performance issues actually. When I was running both Sointu and my intro, the GPU was crying very hard. And I had to I couldn't watch it without audio stutters, and so it was not very pleasant. So in the end, maybe my tool. I was also I put this into a competition, and I was running out of time. So in the last few days, I was just working frantically to get something done before the deadline of the competition.
Yeah, makes sense.
Well, it's really impressive work. Thank you so much for showing it to us. Does anyone else have questions on this demo?
I'm also interested to hear, what we could do, on Gio, or if you want to discuss more on that side, because now we're talking about quite a lot of the tech side of this thing.
I'm not sure I follow.
Yeah, I was just thinking of the because we talk about the widgets already, so and we talk about the examples. So I think that's. I mean, I think that will be that what I would want to see the Gio project. I think it's just it's maybe too early to expect that the average user experience is perfect, and of course don't expect that, but I think that's I think Gio to me starts to look a lot very mature-ish project with all the surrounding infrastructure, and I think that those things will become more important over time.
Absolutely. Yeah. Well, I'll definitely work on making the stuff that isn't in core easier to discover. So I do think that's really important, and I'm sure you're not alone in that. All right. Well, I am going to stop the recording, and then we can go into a more free-form question and answer. So thanks for watching this recording if you did.
Thank you.